Okay, alright. I'm Ismail. I will talk about the today I will talk about the rotary encoder. This is the rotary encoder. If you pause it, then you can see the module. On the module, you can see what uh, the marking here or designator. The first one is clock. We have DT, SW, phase, plus, and ground. So I suggest you to connect the BCC or plus to 3.3 volt better rather than to 5 volt, because some of the pins of the STM32 cannot accept the voltage more than 3.3. So rather than you need to check it, better you ensure that the voltage is at the 3.3 volt. Okay, then I connect the ground here. Then I'm using the pin C2 and C3. C2 for the clock and C3 for the DT or data. Sometimes they call it as A and B pin. And then the push button here I'm not using the push button here. I still connect it to PC10. So that one you need to refer to the nucleo board. So we have PC2 here and PC3, PC10. I'm not using the second line of the header pin because of that one may be being used by, for example, here PA node pin number 28 and PC node PC1, PD2, PD0, PA4 being used by the nucleo, but PC11 by the Arduino multifunction board, right? But you can use this one PC11, for example, here PC9, PC8, and this one you cannot use, right? Because that one being used by the top or by the Arduino multifunction board, 15. So better if you use the Arduino multifunction board, don't use the second or the third header pin or CN6 and CN5. Alright, after you connect it, then you need to know a bit about the rotary encoder. Rotary encoder just producing the pulse that looks like the I don't remember what they call it, the code. What code is that? So the code ensure that the only a change in one line at a time. Gray code, gray code. So if I turn it, then we change from anti-clockwise. So we change from 0, 1, 0, 0, 1, 0, and 1, 1. Then another turns, we change to 0, 1. It repeats that sequence, right? If I turn it clockwise, counterclockwise, or anti-clockwise, then it will change from 1, 0, for example, 0, 0, 0, 1, 1, 1, then change back to 1, 0 and repeat that sequence. Okay, that's we're not interested in that for this time. What we're interested is if you see the timing. So whenever output A change from high to low for clockwise sequence, you can see that the output B at high. Right? I mark those changes, so you can see that. And for anti-clockwise or counterclockwise sequence, you can see that whenever the output A or clock change from high to low, then the data or output B at low. Okay, so we use that to recognize or determine the directions of the rotations, right? Okay, so you know that. Okay, we're going to use the interrupt, right? The interrupt, extended interrupt. So I connect it already to the PC2 and PC3, if you remember. Then this time I will create a new STM32 project. I use that. You can use it from IUC. Sometimes better from IUC, but I just want to show you. Okay, just type STM32 STM. This one is a bit slow. 32 F4O1. Oh, sorry. 1 RE. Okay, and then you got it. Okay, if you got T6, click on T6. Right, so this is the one that we have. All right, so you can click here, right, and then click next. Click next, then we can use. I'm not suggested to use default locations, right? So untick that one, browse to where you want. Okay, so I always put my project in my working folder, right? STM F1 under because it's October 2024, so I will place it here, right? But I click to rename, copy, new folder, then I place it here, then right, then I change name to select my project 007. Okay, select that subfolder. So this is a folder, and then name it. Name it. So we can name it as Rotary Encoder, right? Encoder by extended interrupt. Right? Click to finish. So you will be given the IOC or the SMQMX, right? CQMX. Remember, SMQMX is built in, and it's come with attached to the SMQ IDE. So okay, now we got the IOC, right? Maybe you can go to configuration if you like. Yeah? I set it to say at 66% of the frequency, the maximum frequency, 60. Then go to the pinout, right? I'm going to use the serial port for this example. I click to use that tool, asynchronous, right? Then go to the parameters. These parameters, I love to use 11520, so I just set the default. And I'm going to use serial.1, serial.1, which is serial.1 is I mean the code, the driver, right? Serial.1, which is developed to be to handle the UI in serial.com in interrupt mode. So enable it. No need to enable DMA because it's not support that DMA. Okay, if you need a DMA, then you use the serial.com 2 from my driver. All right. Next, what you do is you go to the. I'm not using the PC10 in the example, so I'm going to use PC2 and PC3. So PC2 and PC3 is here. Okay, so we click to PC3, find out all right, PC13, right? PC3. Sorry, set it as input because we just going to read that push button, not wait for the trigger. But PC2 we need to change it into or select it to GPIO extended interrupt 2, right? And then remember this is falling edge. I select the falling edge. You can use the rising edge, but rising edge is another. So the output B is inverted, right? Rather than high, it become low, right? Okay, so I use PC2, then click in the system view, GPIO, right? Normally this encoder come with the pull up, but you can add the pull up if you do like, but the other one, the push button, if I'm not mistaken, come without the if you see at the back of the better see it, right? The back here, I think one button, one resistor is not there. Yeah, this one, R1, right? R1 is, there is no push button resistor there. That's for the push button. So that must be what the pull up must be enabled, right? But for this you can add pull up, no problem, right? Because pull up just this design is I do suggest no need for to put the resistor, just put the capacitor to ground, right? Ground, then we pull up it internally, right? So it's better to sort out mouse or the bounce problem that we have. All right, next we go to the external interrupt. Remember, we need to change it to polling each, and then go to the system view, click on NBIC, enable the the line. This is the line here. External interrupt to line 2. Click it. You can change it to, for example, like lower. You can lower, right? Lower the priority. I set it to external interrupt 1. You can set it to left it to 0, no problem, eh? No problem, because it's not complicated application, by the way. X, what you do is just generate the code. Right? So the first step, selects the pin, GPIO external interrupt 2, and then go to system view, click to GPIO, right? And then click, select the external interrupt, right? And then, I mean the H, then go to NBIC, enable it. Okay, that's all. Generate code. Got the code already here. Now I'm going to use the alright, I want to enable, sorry, I forgot it. I want to enable the LED, the LED. So I select PE5 as the output. Remember to regenerate the code again once you change your pin or whatever, or peripherals or timer or whatever, right? Minimize it. Then we're going to use, okay, from the driver, I'm going to use 0.1 control, press control, remember to select it, and then I'm going to use SysTick. These two I'm going to use, no others. Then press control and move that one, drag to your include, for example, and then drag that C into source, use C into source. Okay, always open up a bit, just open it, right? The 0.1, copy character TX buffer, makes it become extend into your main code because you're going to use it here. Then type extended interrupt, extend EXTI, control space, enter, place it. Then now include the file pound inc double quote, use a tick, pound inc, then serial com, control space, always use control space. Then okay, the first code, right? We're going to use the now we want to see other we still live now. Just that transmit double quote /n new line /r return carriage and type hi there, right? Okay, that's all for that. You can better you compile it, better you compile it. Better you compile it because you can see either your user is okay okay or not, or I mean either the inclusions of the file or the file is correct or not. Compile it, but I know already my code, and then enter. We're going to use two. Once for two SysTick. One SysTick we use uh, to handle the LED, the indicator later, and the other ones that we use to handle the debounce, handle the debounce. So the first one, so we need to set SysTick to 2. We need to use 2. So we have 0 and 1. So 0 I spared for the external interrupt. So I'm going to use if 1 get SysTick. I'm going to use number 1 for my LED. So T out, say each 200, I will 200 millisecond, I will toggle HAL GPIO underscore T. I'm going to toggle GPIO A, pin number underscore 5 semicolon. Okay, so that's complete the indicator. Now you go to top one here, right? We're going to write the extended interruption, right? We use top down here. So minimize all this, right? Minimize all this, and then expand your driver, expand again further HAL driver, expand again source, find out GPIO.c. Okay, and then click, double click that file to open it up, and then find out the callback here inside this. But this take time, so go to window, show view, and then go to outline. So it will outline all the functions available, right? And then click here, callback, and copy that callback. Okay, and then place it in main. Very simple, that's all, right? Enter. Now, remember, we can have a lot of extended interrupt, right, that enable, right? We can enable a lot of it. Now we have one, but better if you write down code for the filter it out. So if GPIO underscore pin, put the space. So if the interrupt come from GPIO underscore pin underscore 2, sorry, control space. Later you can go to your IOC if you like. Okay, IOC, then you can this one you can change use a label. You can change it to say as interrupt, whatever name you like. Then then you when you write the code here, you can write down only let's say from Rotary. So Rotary, okay, you can define it. Okay, then enter. So we allow the interrupt. We allow interrupt at any time, but we allow it at say 100 millisecond, 100 millisecond to keep out to get rid of that key debounce. Key debounce of the, because the rotary encoder is a mechanical switch. When you turn it, then it will generate some sort like what we call the debounce, key debounce. Okay, next, if that happens, then we check the time already elapsed, or not. So number 0. So we allow 100 millisecond elapsed time. Enter. So now we can check if, now we check the pin, the DT, the data, or line B, right? Or here is GPIO underscore pin, HAL underscore GPIO underscore read, GPIO C, pin C, pin underscore 3, not 2, 3. If that's happened, then we check if that pin 3 already at low or at high. Now if that pin is at high, then we transmit. Okay, you transmit double quote /n/r, okay, clockwise, CW. Okay. Else, if the pin at low, so put exclamation mark here, right? You can use else directly, but I don't know, I love to use else if. Okay, then double quote /n/r, okay, anti-clockwise. Okay, that's all good. That's all. You can compile and run. Minimize this one, right? Minimize it. Okay. You can go to Terratum, right? Terratum. Click on serial and show the stealing. Click OK. Remember, we are using the serial port at 115200. Alright. Then go back here and see. Oh, something down. It's already something down. So, okay, you can press the reset button, to see. See? Reset button. I press the reset button. So you can see here, are you there? Alright. You can see that one. Now, if I turn the, see, I see clockwise, anti-clockwise, right, clockwise, anti-clockwise, clockwise, anti-clockwise. But we can see the response is a bit slower. This is because of, the elapsed time is 100 milliseconds, so it is a bit slower, right? But if you reduce the bounce, then sometimes you got that false trigger, But you can solve that one. Up to you. You can solve it. I'm not so show you the code. That maybe you can use the technique that if that's already right. If you change from anti-clockwise to anti-clockwise, it takes time. It's not allow it. It's not allow it for the first one, but second one then it's allowed. Okay. So that one you can up the speed maybe to 10 milliseconds. Right, 10 milliseconds, because we cannot predict the bounce. The bounce we cannot. I mean the time taken for it to elapse, to stable, right? Time the line to stable, we cannot predict it. Okay, all right. Now I show you. Further, I show you the code. We're going to use the what it calls 7 segment, right? 7 segment. So again, go to the what we call this Excel. Go to AMF version 1. So we have the 7 segments here. I'm not going to talk about it, right? Here, because of this one, I will talk a bit in class later, theoretically, right? But what we need to know that the pins here, we have a pin here. I already converted to STM standard. We have CPDS CTCP, so it is attached to PA8, PA9, and PB5. All the pins is output, from the output from the STM32, and must be set to push pull, because you're going to handle, maybe we can say, or connect it to the IC. IC require 0 or 1, not open. Okay, further go to the rotary encoder, IOC, go to PE8, set to GPIO output, PE9, GPIO output, right? Then another one is go to PB5, right? PB5, GPIO output. Set all that three, regenerate the code. Okay, Now we go to the include again, and source, right, subfolder, and then we go to the driver, find out the multi-learning 7 segment. We have to see and header file. You can drag one by one, but remember, press your control and drag down. Okay, so we have multi-segment there. You can go up to include the file inc, include double quote multi-learning, I think, yeah, multi-learning 7 segment.8. Then you can see a bit here. Actually, we have only two here. Okay, only three functions here. The first functions, second functions, and third function. The first function is to on. You can select which segment you want to on. Now I'm going to on off all of them. This one. So actually, this one is inside the to on it. Yeah, this one on segment, right? You can off the segment if you do like. Okay, now I'm not going to use two, two the higher segment. I just use the lowest two segment. Okay, so I show you the way. Go to main. Go to the okay, here on the code begin to, before you use it, you set it right. So you type what segment, on off segment, right? On off segment. So the first one we're going to off, type off segment. Second one is off segment. Third one, you're going to on. And the last one, you're going to on. Because your number will be at the second or two less significant segment. Alright, for that. And then we require something. What that? We need another tick to handle it. So add that one become 3. Then we can type if get SysTick, okay, number 2, each 4 millisecond. Why is it 4 millisecond? And why 4 millisecond? Because of, if you look at we have the 7 segment here, 1, 2, 3, 4. 4, So we have 4. Right, we need to, okay, we have 4 segment. Alright, in 1 second, we need to refresh the 7 segment at 60 times. So that's 60, right? It means that so the total is equal to 4 times 60. I mean total refresh of all the segment, so 60 times times 4, because you have 4. So the time is equal to 1 over that 124. So you got about 4 milliseconds, right? Okay, 4 milliseconds. Then from the codes, you can see that here we have convert number to 7 segment, because the number is not multiply the segment, right? This one multiply the segment. That means we're going to update 70, 71, 72, 73, 70, 71, 72, 73. How the code? You can read it. Okay, go back to main, then multi likes the segment, right? Complete it. Okay, now we change the code here. Okay, I close. I comment the codes. Right, so you can see the difference that I'm doing. first thing first, I'm going to use, say, a static uint8 underscore t, because I'm going to use one variables that I will increase from 0 to 10, for example, right? So I name it as, say, count equals 0. Okay, so this count, okay, I'm going to update. Okay? I'm going to update the 7 segment, right? I can write it down here and count. Oh, better I use it as the not as the, okay, not as the, what we call, the, I put it the global because I'm going to use it, right, in multi-segment, multiplex later. Oh no, I can use it here. I can use it here. Just Control Z. Okay. Then, if that happen, okay, if that happen, enter. Okay, I will increase the, I will increase the count. Okay? I will increase the count. So I see that I can write down, see, right? Convert number, right? Convert number to 7 segment. But remember, this convert number is only in uint6, 16, right? uint16. So what you need to do, type define it. Oh, sorry. Typecast it. Typecast what? Typecast account. Typecast account later. Okay, so if count less than 10, then we increase the count plus plus, right? Then we feed it to the 7 segment. Okay, so you can see the number up, increase. Each time, okay, each time you turn the push button to the encoder to and clockwise. Then else, if you turn it anti-clockwise, then you check. If your count already 0, not 0, right? Not 0, then you decrease it. Then again you update it, right? Then you update it. Okay. So that's this code. You can see, you can, when you turn it, then it will what? You can see your 7 segment later. Your 7 segment. No more to your serial code, your serial port, no more. You just can see your serial port here only. Okay, when you set it, then you test it. Set, convert 7 segment, just put 0. That means you will see only two number, two number clear. You run it. Okay. So you can see the code. This code in begin to and in while. Then this is code in the GPIO, right? In the callback. This is code. And then remember that we have we include all the 3 files. So this all the three files that we have: multi-learning, SysTick, and SysTick. Same here. Okay, now you go to the edit, clear the buffer. It's already sending down. You can see it. Right. Okay, hide there. Then you see here we have 0 0. Now if I turn it, okay, it changes to 1, 2, or 2, 3, 4, 5, 5, 6, 6, 7, 8, 9. No 10. Oh yeah, because we said 0 to 9. We set it to 0 to 9. Okay, 0 to 9. Okay, I want to 0 to 10, and then I want to take out that what we call leading 0. This one we call leading 0. Right? We don't want that leading 0. So what you do, then you go back here. If less than 11, right? If less than 11, right? You want it maximum 10. Then you go to your multi-learning. You go up, okay? In the multi-learning.h, then comment this one to discard the leading 0. Comment it, compile it. Sorry, better you run directly. Actually, this one, if you see here, I still on the segment, right? But because of we discard the leading 0, 0, same with 0, 0, 0, 1, similar to 0, 1. But we want to discard that 0, right? Discard it. Okay, now I turn it. Okay, so you can see that second segment appear. Now it's okay. You don't have it. Okay, so that's all for this time. Bye bye. You want to know more? Register UniKL British Malaysia Institute. Bye bye.